Fiber optics is the science of transmitting data, voice, and images by the passage of light through thin, transparent fibers. The optical fibers used in fiber optics are sometimes made of plastic but most often are made of glass. A typical glass optical fiber has a diameter of 125 micrometers, μm, or 0.125 millimeters, 0.005 inches. Plastic fibers are made of polymethyl methacrylate, polystyrene, or polycarbonate. These are cheaper to produce and more flexible than glass fibers, but their attenuation of light restricts their use to shorter lengths. In telecommunications, optical fibers have been used to replace copper wire in long-distance telephone lines and for linking computers within local area networks. Fiber optics is also the basis of the fiberscopes used for endoscopy or inspecting the interiors of manufactured structural products. Fiber optics telecommunication uses infrared light in the wavelength ranges of 0.8 to 0.9 μm or 1.3 to 1.6 μm wavelengths, efficiently generated by light-emitting diodes or semiconductor lasers and that suffer minimum attenuation in glass fibers. Through the principle of total internal reflection, light rays beamed into the optical fibers can propagate within the core for great distances with exceptionally concise attenuation or reduction in intensity, making fiber optics the ideal method for transmitting data over long distances. An optical fiber, or optical fiber, is a flexible glass or plastic fiber that can transmit light from one end to the other. Such fibers find wide usage in fiber optic communications, where they permit transmission over longer distances and at higher bandwidths, data transfer rates, than electrical cables. Fibers are used instead of metal wires because signals travel along them with less loss and are immune to electromagnetic interference. Fibers are also used for illumination and imaging, and are often wrapped in bundles so they may be used to carry light into, or images out of confined spaces, as in the case of a fiberscope. Specially designed fibers are also used for a variety of other applications, such as fiber optic sensors and fiber lasers. Glass optical fibers are typically made by drawing, while plastic fibers can be made either by drawing or by extrusion. Optical fibers typically include a core surrounded by a transparent cladding material with a lower index of refraction. Light is kept in the core by the phenomenon of total internal reflection, which causes the fiber to act as a waveguide. Fibers that support many propagation paths or transverse modes are called multimode fibers, while those that support a single mode are called single-mode fibers, SMF. Multimode fibers generally have a wider core diameter and are used for short-distance communication links and for applications where high power must be transmitted. Single-mode fibers are used for most communication links longer than 1,050 meters, 3,440 feet. Being able to join optical fibers with low loss is important in fiber optic communication. This is more complex than joining electrical wire or cable and involves careful cleaving of the fibers, precise alignment of the fiber cores, and the coupling of these aligned cores. For applications that demand a permanent connection, a fusion splice is common. In this technique, an electric arc is used to melt the ends of the fibers together. Another common technique is a mechanical splice, where the ends of the fibers are held in contact by mechanical force. Temporary or semi-permanent connections are made by means of specialized optical fiber connectors. The field of applied science and engineering concerned with the design and application of optical fibers is known as fiber optics. The term was coined by Indian-American physicist Narinder Singh Kapani. Optical fiber is used as a medium for telecommunication and computer networking because it is flexible and can be bundled as cables. It is especially advantageous for long-distance communications, because infrared light propagates through the fiber with much lower attenuation compared to electricity in electrical cables. This allows long distances to be spanned with few repeaters. 10 or 40 bit/s is typical in deployed systems. Through the use of wavelength division multiplexing, WDM, each fiber can carry many independent channels, each using a different wavelength of light. The net data rate without overhead bytes, per fiber is the per-channel data rate reduced by the forward error correction, FEC, overhead, multiplied by the number of channels, usually up to 80 in commercial dense WDM systems as of 2008. For short-distance applications, such as a network in an office building, see fiber to the office, fiber optic cabling can save space in cable ducts. This is because a single fiber can carry much more data than electrical cables such as standard Category 5 cable, which typically runs at 100 Mbps or 1 Gbps speeds. Fibers are often also used for short-distance connections between devices. For example, most high-definition televisions offer a digital audio-optical connection. This allows the streaming of audio over light, using the S/PDIF protocol over an optical T/S-link connection. Fibers have many uses in remote sensing. In some applications, the fiber itself is the sensor. The fibers channel optical light to a processing device that analyzes changes in the light's characteristics. In other cases, fiber is used to connect a sensor to a measurement system. Optical fibers can be used as sensors to measure strain, temperature, pressure, and other quantities by modifying a fiber so that the property being measured modulates the intensity, phase, polarization, wavelength, or transit time of light in the fiber. Sensors that vary the intensity of light are the simplest since only a simple source and detector are required. A particularly useful feature of such fiber optic sensors is that they can, if required, provide distributed sensing over distances of up to 1 meter. Distributed acoustic sensing is one example of this. Common uses for fiber optic sensors include advanced intrusion detection security systems. The light is transmitted along a fiber optic sensor cable placed on a fence, pipeline, or communication cabling, and the return signal is monitored and analyzed for disturbances. This return signal is digitally processed to detect disturbances and trip an alarm if an intrusion has occurred. Optical fibers are widely used as components of optical chemical sensors and optical biosensors. Optical fiber can be used to transmit power using a photovoltaic cell to convert the light into electricity. While this method of power transmission is not as efficient as conventional ones, it is especially useful in situations where it is desirable not to have a metallic conductor, as in the case of use near MRI machines, which produce strong magnetic fields. Other examples are for powering electronics in high-powered antenna elements and measurement devices used in high-voltage transmission equipment. Optical fibers are used as light guides in medical and other applications where bright light needs to be shown on a target without a clear line-of-sight path. Many microscopes use fiber optic light sources to provide intense illumination of samples being studied. Optical fiber is also used in imaging optics. A coherent bundle of fibers is used, sometimes along with lenses, for a long, thin imaging device called an endoscope, which is used to view objects through a small hole. Medical endoscopes are used for minimally invasive exploratory or surgical procedures. Industrial endoscopes, see fiberscope or borescope, are used for inspecting anything hard to reach, such as jet engine interiors. In some buildings, optical fibers route sunlight from the roof to other parts of the building, see non-imaging optics. Optical fiber lamps are used for illumination in decorative applications, including signs, art, toys, and artificial Christmas trees. Optical fiber is an intrinsic part of the light-transmitting concrete building product Litrocon. Optical fiber can also be used in structural health monitoring. This type of sensor can detect stresses that may have a lasting impact on structures. It is based on the principle of measuring analog attenuation. Fiber optic internet, commonly called fiber internet or simply fiber, is a broadband connection that can reach speeds of up to 10 gigabits per second, Gbps, in some areas. The technology uses fiber optic cable, which amazingly can send data as fast as about 70% the speed of light. In addition, fiber optic cables are not as susceptible to severe weather conditions as other types of cables. These sturdy fiber cables have minimal outages as compared to others. They also resist electrical interference. Fiber is ideal for homes or businesses with multiple users connecting several devices at once. Fiber service allows you to upload and download files quickly, Enjoy buffer-free online gaming and video chatting. Back up your entire hard drive to the cloud, including large photos and videos, in minutes instead of hours. Download a 2-hour HD movie in seconds, compared to waiting 30 minutes or more over a 20 Mbps DSL internet connection. Fiber optic internet is a complex technology that allows the transmission of information in the form of light rather than electricity. There are many pieces that make up this advanced technology, but two key components are optical fibers and the so-called last mile of the fiber optic network. Optical fibers are tiny, about 125 microns in diameter, or slightly larger than a human hair. Many of these fibers are bundled together to form cables, not to be confused with coaxial cables, which are made of copper. The optical fibers carry pulses of laser or LED light down the line, transmitting information in binary form, similar to the zeros and ones used in electronics. Once these superfast pulses of light reach their destination, they are converted into electrical output that your devices can understand and use. This is performed by a special piece of equipment called the optical network terminal, which then sends the signal through an Ethernet connection to the end user. The stretch between the main fiber network line and the end user is referred to as the last mile, though it is often much shorter than a mile. Pure fiber refers to fiber connections that run all the way to the end user's home, business, or desktop computer. This is the fastest and most expensive last mile option, as it brings the full speed and reliability of fiber straight to the consumer. As an alternative, copper cables are often used to carry the fiber connection from a terminal called a street cabinet to a whole housing block, campus, or residential building. This option is less expensive, but a small amount of the fiber speed is lost in the last mile. Though many people think of fiber optic as a new technology, it actually dates back to the 1970s, when it was first used in telecommunications. In 1988, fiber optic cables were laid beneath the ocean, connecting the US to Europe. Over the years, more and more lines were laid under the sea, so today a huge network of fiber optic cables stretches around the entire globe. Growing fiber networks, with their high-speed capabilities and reliable transmission of data, have allowed for dramatic progress in the telecom field. In fact, some say fiber optic technology is what made the information age possible. In developed nations, fiber optic lines replaced the older copper lines years ago, forming the core or backbone of our current internet networks. Only recently has it become more cost-effective to install fiber lines than copper ones. So, as the technology keeps improving, fiber optic networks are expanding rapidly across cities and directly to homes. How is fiber different from other types of internets? The main difference is that fiber doesn't utilize electric current like other types of internet connections do. It uses light, delivered through the fiberglass core. Internet technologies have evolved dramatically over time, from dial-up connections to broadband technologies like DSL and cable. High-speed internet connections transmit data at different speeds. In addition to being faster, fiber is widely considered to be more reliable, thanks to fewer outages and electrical interferences. CenturyLink fiber service can deliver symmetrical download/upload speeds of up to 940 megabits per second, (Mbps), over a wired connection to your router. In thinking about speed, you can't ignore the impact of Wi-Fi. The everyday connection speed you experience can be limited by the use of wireless technology, which tends to lose signal strength, meaning reduced bandwidth, as compared to the wired connection that enters your router. Fiber internet is a great choice for high-bandwidth households or businesses where multiple users want to stream video, play online games, back up data, or send and receive large files at the same time. A fiber-connected home or business can deliver an exceptional experience across all devices and internet-connected systems, from home security to smart thermostats, ovens, refrigerators, and other appliances. With faster speeds, you also don't get as much buffering with on-demand streaming. Buffering refers to the loading time that occurs when a video pauses and has to catch up. Fiber internet from CenturyLink, for instance, lets you download a full-length 4K or HD movie in seconds. You may have heard the terms dark fiber and lit fiber and wonder what they mean. Well, it may surprise you to learn that the biggest cost of building a fiber optic network isn't the cable itself, but the cost of digging up the ground to bury the cable. So, once they've completed the digging, many telecommunications companies lay down extra fiber optic cables to enable future development. Dark fiber refers to those cables that are not yet being used, while lit fiber refers to the lines that are already connected, or lit, and are being used by telecom companies to deliver fiber internet services. Thank you for watching this video.